Okay, welcome back everyone to this tutorial series on the theory of computation. So in this video, we'll be looking at reviewing another mathematical proof technique. And in fact, we'll be looking at a particular mathematical principle that's used in a lot of proofs in this course in particular. And this sort of principle is known as the pigeonhole principle, which is a funny name. Um, but it's a good mnemonic to sort of remind you of what exactly is going on. So the setup is, suppose you have n pigeon holes, right? So, you can imagine pigeons or birds, and you have a bunch of pigeonholes, right? So you have these wooden boxes, and then in each of these wooden boxes has a hole where a pigeon can go and can sleep during the night. Okay, and suppose you have n of these, right? So I'll number them from 1 all the way to n. Okay, and so the pigeons, what they can do is once they come back from a long day of working, of doing pigeon stuff, they come back to this set of n pigeonholes, and they pick one to sleep in for the night. So you can imagine, let's say, you have pigeon 1 that is going to choose to go in the first pigeonhole, let's say. And then you have pigeon 2, maybe that pigeon decides to go in the third pigeonhole, okay? And so on, right? So in particular, suppose that you have not n, but n plus 1 that come home to try to nest or to try to sleep during the night. Okay? So, what has to happen in this case is that there must be a pigeonhole with at least 2 pigeons. Okay? And so the intuition behind that is, suppose the first n pigeons each go in a distinct pigeonhole, right? So suppose each of these gets very lucky and they can sleep all alone for the night in a separate pigeonhole, right? So suppose pigeon 1 goes in here and doesn't find anyone, pigeon 2 goes in here, doesn't find anyone, and so on. Suppose pigeon 3 goes there, pigeon 4 goes there, and pigeon n, suppose, goes into hole n, right? So suppose each of these pigeons has a separate pigeonhole, it has a separate home for the night. Well, once the nth plus 1, right, once the n plus 1th pigeon comes and tries to find a place to nest or a place to sleep for the night, it'll have no choice but to go and share a pigeonhole with another pigeon, right? Because from the n pigeonholes that it can select, each of them is taken by a pigeon. And so whatever pigeonhole it chooses, so suppose it chooses, without loss of generality, suppose it chooses pigeonhole 3, then there's already a pigeon in here, and so the n plus 1th pigeon will also be in this pigeonhole, right? And so there's going to be this particular pigeonhole with 2 pigeons, okay? But note, it doesn't say, the pigeonhole principle doesn't say that there is exactly one pigeonhole with exactly two pigeons, right? That's not what it's saying, because you could think of a scenario where all of the pigeons want to sleep together because they're a whole big family, and so they all go in the same pigeonhole. Let's say pigeonhole 1, right? Um, but that doesn't invalidate the pigeonhole principle, because what it says is that if there are n plus 1 pigeons, okay, and you have n holes, okay, n pigeonholes, right? And so here, the term occupying is slightly misleading. What we really mean is you have n plus 1 pigeons and they can choose from n pigeonholes, right? So really the correct, if you want to have this really precisely down, is n plus 1 pigeons choosing, let's say, to stay in n pigeonholes, okay, then what will happen is that at least one of these pigeonholes will be occupied by at least two pigeons, right? So there must be at least one, right? So this is how you read this mathematically. At least one pigeonhole will have at least two pigeons, right? Or, in other words, if you want to write this um, in a quantifier notation, you could write something like there exists a pigeonhole P such that there exists two pigeons, let's call them A, B, two pigeons, such that A and B are in P. Okay, and this is definitely very loose quantification notation, or quantifier notation, but this gives you the gist of the idea, right? And so this is what the pigeonhole principle tells us, okay? And so now what we're going to do is we're going to use the pigeonhole principle to actually prove a mathematical statement.